I had the opportunity to talk with a data science person at Twins. They're focused on right now is not so much the in-game analytics portion, but the contract dispensing. Okay, this player's this age, he's done this in the past. There's this stat called WAR, W-A-R in baseball, and it's wins above replacement is a measure of how many extra wins you can expect from having this player compared to the league average. This is where explainable AI comes in again. You sort of need to go to the player's agent and say, this is the reasons why we're thinking this number. You can't say this number.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry and connect with us to learn more about our organization at AppliedAI.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today we have Parker Erickson. Parker is currently a student at the University of Minnesota, pursuing a BS in computer science. He's interested in machine learning, artificial intelligence, and graph databases. He's also been a software engineering intern at Optum and has developed, among many things, a fraud detection system using graph databases and working on machine learning. The system is currently in the patent process. I also just learned, Parker, that you were an Eagle Scout. So that's really awesome. You have a lot of experience working and leading teams and lots of cool stuff. And I'm curious to touch a little bit about that during our conversation. So welcome, Parker.
Thanks.
Cool. Well, I think I recall initially meeting you at one of the Coder Dojo events, like way back when you were in high school. It seems like computers and technology have always been sort of a passion of yours. I'm sort of curious to know kind of what got you into it.
Yeah, so all started around, I'd say, 4th grade or so. Did a summer camp of Lego robotics at the Works Museum. That time they were in Edina. And they were like, oh, we have a first Lego League robotics team. Makes this robot program to do different missions. There's a research project with it. It might be something that you want to join.
Mm-hmm.
And so from 4th grade on to freshman year of high school, I was on a Lego robotics team every season. So that was sort of the kickstart of programming for me. My mom saw an article in the newspaper about, how to get kids involved in coding. And I mean, I was already on this Lego robotics train, and they mentioned Coder Dojo. I mean, it was really early in their founding. I went to a couple of events, started playing around with Arduinos, Raspberry Pis, that sort of area of the world. Really sort of just loved playing with it. I mean, just, trying different stuff out. Met some great people like you and Dan McCreary, Matt Gray, have really sort of helped keep me interested and keep me involved in the field. So
nice. And so you talked about Arduinos and Raspberry Pis and stuff like that. Is you think there's sort of a innate passion of yours around controlling things, motors and physical things, or are you? I mean, it seems like you're pretty open. Obviously, you're doing a lot of other things that are not sort of like device related, but was there a piece of that, I guess, as a part of this, as you sort of got into this?
It's cool to see something move that you programmed to do what you told it to do instead of, just seeing text pop up on a screen. It's sort of, that's why robotics and Arduino is such a great tool to get kids into the field, is that it's a lot more physical of, hey, I actually made that thing move or change color or whatever else, versus, hello world popped up on the screen. Great.
Sure.
I think that's sort of one of the new initiatives at Coder Dojo is this AI Racing League donkey car building thing. And I think that is, a really good way to expose kids to AI because it's physical and you can see, oh, I drove it around the track, so it learned how to do this. we train a model, and then we can see how well it does.
Right.
And
Right.
if I'm really bad at driving, it's not going to be good at driving by itself.
Right.
You know,
Right. Yep. Yep. For sure. Um, yeah, we had Dan on a couple episodes ago, and he talked a lot about the AI Racing League. Now, so you sort of attended Dojo as a student, what have you, sort of interested in the stuff. You've now been very much sort of like leading, right? You kind of help more on the educator teacher side, right?
yeah. So I think I started mentoring at Dan's encouragement in 2014 or so.
Mm.
So that would have been my freshman or sophomore year of high school. Um, and it's, taken off from there. Have stayed mostly within the Arduino and uh, robotics, you know, groups at Coder Dojo. But it's a lot of fun seeing the kids and helping them. They get into rabbit holes of their own curiosity. Like one kid recently um, was like, "So how exactly does binary work? And how much faster is this computer versus this Arduino?" And I just came out of the machine architecture class in school
Hmm.
this past fall. So it was like, okay, yeah, I can go through and try and dumb this down. Well, not dumb it down, but
Make it a little more simple.
break it down to something that's understandable instead of reading this college level textbook for you. Yeah.
Sure, sure. Well, I think this may or may not be true, but I mean, you're in a little bit more of the closer age category with these people. And do you feel like that maybe has a little bit of a benefit to you?
Yeah. I mean, it's, I think you have to, I think with kids, they always look up to older kids. They don't necessarily look up to adults. Like, there's big age gap in between,
Yeah,
or at least in their heads of like, okay, well, I'm still in school and this adult has been in the workforce for even just like 2 years, but that's a huge difference versus, oh, he's just in a, higher level of school.
yeah, sure.
I think it's fun to interact with them. And I always end walking away learning something new from them. It's sort of amazing of how does this work? And you're like, oh, that's a good question.
Right, right. Yeah. They can sometimes challenge you to try and figure stuff out, they ask
Yeah.
questions that you hadn't even thought of, so it can force you
And
to
then
explore
it's
things.
diving down the rabbit hole of Google with them, which, is part of the process
Yep. Yep, for
is
sure.
having 50 Stack Overflow tabs open.
Yeah. Awesome. Yeah, yeah. Very cool. So you're doing this mentoring, you start in college then, interested in computer science, obviously, taking classes. Did you get into any of like the first robotic stuff at all before I maybe like move on? But did you touch some of that?
The Lego Robotics League is under the first umbrella. The high school that I went to, the first robotics league or the team was not very well organized and run.
Hmm.
Like the activities director at our school refused to give us funding. It was just sort of a mess, so I didn't really get
Pursue that.
involved that much with it.
Uh-huh.
Was very much a band kid and did quiz bowl in high school. So
Okay. Well, cool. Well, so then you started interning at Optum, and probably that's where you really started diving into this whole machine learning AI stuff. Is that safe to say?
yeah, I mean, I played around with it, on my own time.
Mhm.
Nothing really hugely inspirational. Like I played around with some genetic algorithms for route planning. Like you could put in a list of cities, and it would figure out, the optimal path between them, and just some like handwritten digit
Oh,
classification. The hello worlds of ML. So yeah, then this past summer I was at Optum. There was a group of 5 interns. We're on a team that was fraud finding focused. So be it
mm,
in health savings accounts or like claims fraud, a phony doctor, phony claim,
Mm.
stuff like that. I've known Dan through Coder Dojo, and he, is the graph evangelist, for lack of a better word,
Yeah.
uh, at Optum. He introduced me to John Herkey as well. When I told him that, the task, basically the task that was given to us for the 5 interns was like, use machine learning, find fraud, go.
Very open-ended. So,
Yeah. It was basically a blue sky, just like come up with a solution.
wow, sounds fun.
And yes, it was great.
Maybe a little bit daunting too, I guess, but
Yes. No, and so I was telling both Dan and John this, and they're like, the number one use for graph is fraud finding, right?
mm.
And I'm like, no, but okay. And Optum's, driving towards this graph platform of
Yeah.
basically everything's integrated in this massive knowledge graph.
hmm
And so they were like, well, you should look into it, try it out. So get the demo Docker version of Tiger Graph going
Okay.
and model up, these relationships from the data. This person has, this account, things like that.
And they file
Uh,
these claims, for example. It's
yeah,
kind of what you're
I
looking
mean,
for.
can't go too far into depth with it, but
Sure, I understand.
yeah. And so we modeled it up. We also was looking into different graph algorithms to actually, and so like some community finding algorithms we looked into,
Hmm.
some similarity algorithms we also looked into. What we settled upon was this thing called a graph convolutional neural network.
Oh yeah, it's kind of the new hot buzzword these days. It seems like, right?
Yes. And so there's a couple different graph-based neural networks that I haven't tried yet, but look cool. But anyways, this graph convolutional neural network, or a GCN,
GCN.
uses basically the adjacency matrix of this graph. So in this matrix, if vertex 1 is connected to vertex 2,
hmm
there's going to be a 1 in the matrix 1, 2, and the matrix 2, 1 if it's a undirected graph. And so like a traditional convolutional neural net based on images works off of adjacent pixels
Yeah,
and combines them and finds the edges and stuff like that.
and in those cases, basically, it decides if it's going to fire or not. Kind of a 1 or a 0 type thing.
Yeah, instead of adjacent pixels, it works off of nodes or vertices that are connected within that graph.
Gotcha.
It can classify each node based off of this adjacency matrix.
Huh.
The great thing is that since you have this graph, each each convolutional layer takes one step farther away from a given vertice in the graph.
hmm
So you can see exactly based on how many convolutional layers you have, what the algorithm looked at in the graph
Oh.
to classify this node. So like if you have 2 layers, you can look at your neighbors 2 hops away in that radius
hmm
of, okay, I have 3 neighbors that are directly 1 hop, and then each of those neighbors also have 3 neighbors. So you end up with, you know, those 20 some odd neighbors
Uh-huh.
that you can go, oh, okay, this is what it saw when it classified this vertex.
Gotcha. Gotcha.
So it adds a little bit more context. It's not, explainable, but you can at least distinguish a little bit more patterns there.
Sure, sure. Yeah, I think that's been the hardest thing. I think just with neural nets in general is that I've been experienced with like TensorFlow is there's dials you can tweak and different sort of weights and measures you can do, but at the end of the day, it sort of spits it out and it's still kind of a black box, right? Like I understand that you got from A to B, you may or may not be correct, but I don't really understand, at least visually, like
Yeah,
how you actually did that. So the whole sort of GCN stuff sounds very fascinating to me because the whole power that I've seen in graphs too is just the whole visualization of it. Like and you can like take all these nodes and you can hop from one to one to one to one to the other, and sort of just in a traditional graph database sense, be able to trace your steps sort of through point A to
Yeah.
point B.
And like even before we figured out this algorithm to use, and I mean it's a published algorithm, the hip and whaling is or welling is the big, go-to paper on GCNs. We were just, playing around with the data in Tiger Graphs, GUI, and like we saw patterns that were like, yeah, that's fishy.
Mm-hmm.
And what do you know? We've already, found them as fraud. But, just seeing it visualized of,
Yep.
it really shows how easy it is to find those types of patterns in a graph database instead of
Sure.
joining who knows how many
Tables in
tables.
SQL. Yeah, exactly. I mean, in some ways, it's a picture's worth 1,000 words, I guess. And so humans are very good at looking at these relationships and picking them out. And computers, of course, are better at looking at even more and trying to connect the dots. But I think there's a lot of intuition that we can do just visually looking at data. That's like really cool. So you focused a lot on that. And graph databases were new to you, I guess, coming into your internship last year. And so what you're planning on being an intern this year too. Is that true?
Yep. I'm also going to be at Optum this summer. Different team. I'm not exactly sure what I'm going to be doing yet.
Nice.
Start in 2 weeks, but we'll see what happens.
Nice.
It's going to be all virtual this year, obviously. So that'll be an adventure within itself.
For sure. Well, one of the questions I ask people that come on the show is, do you have a definition of artificial intelligence? Based on what you've done so far, do you have like an elevator pitch, or is it still pretty squishy? Is it just sort of still tough for you to formulate an opinion around that?
I think it really depends on how deep you're going into AI as a term. If you're, going the Terminator, Skynet, AI, that's, I think, a long way off, just even from a computing power standpoint of things. But if you're talking narrow, classify this image,
right?
Drive this car, I think that's a lot easier of a definition of it's a way to learn from the data that you give it. It's the process of the way I like to think of it is everything is some form of a function that you have your images or your other inputs as X, and you have your desired output as Y. AI just figures out what combinations of X give you Y, is the way I like to sort of boil it down.
Yeah, for sure. And I guess the power of machine learning and deep learning is just that we can do it so much faster these days with more data. Would that be a true statement?
I wasn't around in the days of not enough compute, not enough data. But yes, I would tend to agree with that.
Yeah, sure. Do you think, I guess, that then any thoughts on generalized artificial intelligence? I mean, if we get enough data of everything, is there a way to create it such in a way that it would just be generalized enough? Or do you feel like we're sort of always in this sort of like classify this one little thing? Because that's where it seems to break down today.
Yeah, I've sort of started to look into reinforcement learning. Watched a documentary called AlphaGo. It's free on YouTube. It's about the DeepMind team that beat the world champion in Go. And I thought it was, a really interesting take on the learning process of I'm going to play against myself or, some sort of human, and I'm gonna give myself a reward every time I win, or make this move, and I'm going to give a negative reward if I lose.
Right.
And I mean, when you think about it, like learning to walk or something, is probably along that line of reinforcing the connections in your brain to balance yourself and move yourself forward. And if you fall, the brain is probably saying, okay, well, that didn't work out.
That's a negative.
Yeah. There's a lot of neuroscience that I don't understand in that, but I think that's from a logical standpoint, it makes sense to me that that's the way to generalize a little bit more.
Totally. Yeah. So you don't program against a set of rules. It sort of learns the rules along the way. You never really say, if you bring it back to chess then too, like you don't really say a knight moves in this specific way or a bishop moves this way. It just evaluates so many different moves, and it starts to realize, oh, in order for me to win, this is what I
Yeah.
need to do.
I mean, you still have to program the rules of the environment per se of, yes, this chess piece has to move this way or whatever.
Right.
But other than that, I mean, just saying that the knight, makes the L shape, that's all you give it. And then
Right.
it plays against itself and
Plays
figures
against
it.
itself, and it starts to realize, yeah, I don't know if it was AlphaGo or if it was chess, but there was a book that I was reading recently where yeah, basically they were able to train an algorithm basically to learn how to play chess in 4 hours, and it
Wow.
basically took in all the possible moves that it could in the entire universe in terms of like what we knew today, like basically how all chess games started and how they all ended and all the steps that went through. And it was fascinating that they said, in 4 hours now this computer is essentially smarter than any chess player in the entire world. And
Yeah.
it was just and it had technically learned how to do it. Nobody sat down. I mean, they sat down and trained it. We trained it really, really fast, but nobody went through. It's not an algorithmic programming. And this is what's interesting to me as a software engineer. I've been doing this for 20 years. We're always sort of have been programming algorithms, if then, conditional statements, this type of stuff. And I've heard this term software 2.0, which is basically it's a black box, and you're twisting dials and you're feeding data into this thing, and then it gives you the outputs, and you're no longer coding anymore.
I think that's a really cool idea of where it's going.
Hmm.
But there are, the healthcare field, I'm sure, this has been mentioned by Dan and probably John. Doctors don't just accept, give them this drug as an answer.
Yeah.
That's the problem with the black box.
Yeah.
AI will have made it if we can get something to the point of deep learning accuracy with the explainability
Yeah.
portion added in.
Sure. I think there's this whole storytelling aspect, to it, where with regards to, it's not just, hey, here's our in and here's our out. Here's how it really is relative to the problem. And I was just talking to a guy recently, and he said one of the things that he's been running into is yes, it works today. Like you give it an input and you get the output and it all makes sense. A lot of people don't go back and retrain their algorithms over time to get to basically make sure that 6 months from now it's still working the way it was in the past. And if it's not working anymore, then there's probably a lot of other data that you don't have enough data. You had a snapshot in time where it worked, but that doesn't mean it's going to work forever.
Yeah. Changes in society in the past 2, 3, 4 months will have sort of proven that, look, these are very brittle systems.
Mm.
The data collected in the past, 3 months of the pandemic, there's been, nobody can just predict a pandemic out of the blue and go, okay, I mean, humans can't do that. We've lived through nothing like this before. We can't say how, supply and demand is going to change or not. We can't say really anything, much less expect an algorithm that we fed in semi-clean data in regards to, look, this is an event that the world has never seen before.
Yeah. It's the unknown unknowns, I guess.
Yes.
There's a book that Nate Silver put out called The Signal and the Noise, and he talks a lot about that in there, where there are cases, instances where this just wasn't even thought of. This just wasn't even put in the model. So we're sort of in a new, completely different era.
So it'll be interesting how this spurs change, if it does,
Yeah,
if it spurs change in the algorithm, the deep learning, machine learning community of,
sure.
look, these are brittle compared to world events.
That's a great point. I want to focus a little bit on maybe a project that you've worked on, just personally. I think you've mentioned in the past you're going to be speaking at an upcoming event of ours on a pitch prediction algorithm. I'm curious to know a little bit more. I mean, could you talk a little bit about that project and everything from getting the data to like, is this going to improve over time? I don't know. Give our listeners a little bit of background on this and what you worked on.
I worked on this over winter break mostly, and spilling into the spring semester. Essentially, I was when the news of the Astros sign stealing scandal
Uh-huh.
broke. I was like, do you really need a well, I guess to back up,
Uh-huh.
over this past offseason of baseball, it was revealed that the Houston Astros were stealing opposing teams' pitching signals through a camera in center field that would look at the catcher's signals to the pitcher,
Hmm.
and then they would communicate whether a fastball or not a fastball would be coming based on banging a trash can in the dugout.
Right. Yep. Remember hearing about
The title of the blog article that I wrote was "Do You Really Need Trash Cans?"
that.
sort of in response to this whole thing.
Yeah.
And I was like, okay, well, can you just, in some situations, me as a layperson baseball fan can go, oh, there was a breaking pitch low and outside. They might go with the fastball on the inner half of the plate and maybe up to throw them off. I'm like, okay, well, if I can do that, can machine learning do it?
Mm.
The great thing about baseball is that they have a system called StatCast.
Mm.
And so every single pitch is recorded into this data set to every single hitter, you know, the runners on base. You can get what the previous pitch was because you can just look at the previous pitch entry.
And
You
this is
can,
all open. Open. You can just go
yeah,
out to a website and download all this data.
yeah,
What format's it in? Is it all like a CSV file or something?
pretty much.
Okay.
There's a Python package actually called PyBaseball, I believe.
Oh, neat.
And so you can basically say, I want all games in between these range of dates, and it downloads it for you, and you get a pandas data frame.
It's cool.
Like it's it's
Super
about
cool.
as easy as it can be.
Nice.
Um, but you can get, the pitch thrown was a curveball, it was a slider, it was a fastball, whatever
Mhm.
pitch it was,
Hmm.
as well as the velocity of those pitches.
Oh, neat. Okay.
If you really wanted to dive into it, you can also get like the spin rate off of the pitcher's hand of the ball because there's cameras in the MLB stadiums that track the ball. They might be radar actually. I'm not exactly sure, but
Sure. Yep.
tons
During
of
its flight.
data.
Yeah. No, I
Yeah,
remember.
I basically narrowed it down to the running situation of who's on base, the previous pitch, the score, and the inning, something like that.
Okay.
Because I don't want, I mean, nobody's going to be able to predict a pitch by looking at the spin rate in real time and communicating it while the pitch is coming towards home plate.
Right. Right.
So it had to be the data that was, available before each pitch. And so basically what it boiled down to was I fed this into a neural network. I tried some other machine learning models with it as well. But they didn't pan out very well. And I was able to train a model with about 75% accuracy. It was determined that the Astros had about a 93% accuracy rate
Hmm.
on stealing the signs. So a far cry from what I was managing to do with machine learning. I mean, it was debatable whether the Astros really gained that much benefit from it in the first
Right.
place.
Right.
Because I mean, even if you know a fastball is coming, it can be anywhere in a strike zone. And it's still hard just to get a bat on a 93, 95 mile per hour ball being
Fastball.
thrown at you.
Sure, sure.
So the jury is still sort of out whether it really had any uh, effect.
Positive
Some
impact.
say that it did have a little, but it was pretty negligible. Um,
Did
but
they
yeah,
did I was wondering if anybody went back and took a listen to audio from some of these games. And I remember my wife, she's an avid baseball fan. So am I, but not nowhere near to the extent that she is. But she had said that they had gone back and they were listening to and watching prior games, and it was like you could hear this garbage can being shaken at various times. And sure enough, fastballs came in. But I don't know if that was ever analyzed by anybody as far as or if that's another piece of data you could bring into this.
yeah. So that's about where the 93% accuracy metric came from,
Okay.
is that somebody did go through the entire 2017 season and listened to every single game.
That the Astros were in, and every
Yes,
pitch that was thrown.
yes, and basically was listening for a trash can bang and marked it down if it was a fastball.
Sure.
Yeah, so there's a couple different ways that I'd like to take this in the future, and the first is really only takes in the previous pitch. I would like to use like a LSTM net or some sort of sequence neural network that can handle a sequence of pitches.
So all the ones sort of leading up to it,
Yeah.
right? That's where
So like,
LSTMs are powerful, is you can get a whole range of things to pull into that one prediction. Is that true?
yeah, like get the entire at bat. So like not only just the pitch previous to it, but if this is a 5, 6, 7 pitch at bat,
Mm-hmm.
get all those pitches into a form where it can make a prediction and see if that has any helpful, even pitchers, it could specify, find pitchers that are using the same sequence of pitches more often, or, patterns with that, which would be, more helpful.
Yeah, for sure. You got me thinking about, I mean, I'm sure pitchers have signature, whether they know it or not, they probably gravitate towards certain sequences of pitches, right? Start off with a fastball, most of the time, curveball here, that, or the other stuff. And that's probably what a lot of those signs are that
Yeah.
of course, teams are spending a lot of money on analytics, and they're using the StatsCast data, obviously, and trying to build the best algorithm and hire the best data scientists that they can for them just infer to any hitter, you're probably going to be getting this coming at you, regardless if a garbage can bangs or not, right?
Yeah.
There's a lot of interesting things that can be done based on just the data that's out there.
Yeah. No. So another place where I want to look into is like sort of in the AlphaGo realm. Okay, let's see how we can best manage our lineup. Have a baseball simulator. How do we organize our lineup? How do we manage our pitching staffs so their wear is lower, or less injury prone, but we still, maybe the best way to go is having 9 pitchers each do an inning.
Right.
Maybe it's not having a starter go, you know, 6 innings, 7 innings, and closing it off with some relievers at the end.
Yeah. Wow.
AlphaGo, there was this one move that basically was astounding to the entire Go community. And now I'm not a Go player, so I can't really explain it.
Right.
But there was a moment of creativity by the computer of going, well, that doesn't make sense, to
Yep.
the traditional Go community. That ended up to be a genius move.
Totally. Yep.
So what if we apply a baseball simulator, apply this to managing those lineups and managing pitching matchups, and see what happens?
Sure. Sure. No, that's, yeah, you as you were speaking, it totally made me think about, um, you know, as the coach, they need to create a lineup for the team. Um, they're basing that off of, I mean, I think best gut and like, okay, here's our usual. It probably is also a little bit more with regards to who is resting and who's not, and stuff like that, rather than, gosh, what if you shifted the lineup? I honestly don't know if it's possible to shift the lineup during the game a lot, but it was just like, you brought in a new pitcher. Now I'm going to completely rejigger this thing, or this pitcher has pitched this way for the first inning or so. I'm just going to shift up the team now because based on the way he's pitching today, he's not doing the same things that I thought he would when I started the game. So could you evolve, your players that are up to bat during the game? And that would be like, who's ever thought of that before? I guess.
Yeah, I had the opportunity to talk with a data science person at the Twins. They're focused on right now is not so much the in-game analytics portion, but the contract dispensing. Okay, this player's this age, he's done this in the past. There's this stat called WAR, WAR in baseball, and it's wins above replacement. So it basically is a measure of how many extra wins you can expect from having this player compared to the league average.
Wow.
Essentially.
Uh-huh.
Their focus is getting the best contract deals based on, okay, this player is projected to do this WAR in the next 3-4 years.
Sure.
Or renegotiation. And this is where explainable AI comes in again, is that you sort of need to go to, player's agent and say, this is the reasons why we're thinking this number.
Yep. Yeah, exactly.
You can't say this number.
Yeah, we have to have some data behind it. I guess if you compare it to basketball, it's like, look, I wonder what the WAR score would be for Michael Jordan, right? But it has to be phenomenal. You're basically looking for these people that are aces, and because of them, you can point at certain wins that are going to happen, and they're probably looking for those. Same in baseball, and there's probably certain players, obviously, that those are the guys that are getting paid the big bucks because they actually have an influence over the outcome of the game.
Yeah, or you look at the Moneyball approach of, okay, what players are the most influential that we can pay the least amount of money for because we're, the Oakland A's and have a low budget.
Right.
And, what's the maximum number of wins we can get with this budget?
Right, out of that person, for example.
Yeah. What's going to give us general AI is going to be a combination thereof.
So very interesting project, and I'm super excited to hear sort of more about it. And by the time this airs, you might have already had the meetup, but we'll be recording it, and I'll be sure to share it in the liner notes and all the stuff that we've been talking about for this podcast. So one of the things that I did want to touch on a little bit was just I don't know, I guess any advice or classes or books that you've read, or meetups or other groups and stuff like that. Obviously, you mentioned Coder Dojo. I guess people that are your age or below, or even changing careers, whatever, that are interested in sort of this field. What would you tell them?
Yeah. So as far as books, The Master Algorithm by Pedro Domingos, really good overview of sort of the 5 different camps of machine learning. It's, the deep learning neural net guys and the decision tree and the, more traditional like linear regression, genetic algorithms. And it sort of gives you a good overview of all those, and then sort of makes the case that what's going to give us general AI is going to be a combination thereof. And I would throw reinforcement learning, which was a good experience to get, as well as our final project was predicting a house selling price. So we had to, it was a group project, we had to scrape Zillow for, the information like how many bedrooms, bathrooms, whatever. We requested access to the Minnesota Department of Revenue's sales records, because that's all freely public information. You just have to request access for the database, and you can
Hmm.
download a ton of XML files.
Hmm.
And we use that for like the addresses of recently sold properties, as well as the actual selling price.
Nice.
And then we also scraped Zillow for images. And so we would take the preview image for Zillow and run it through a image not classifier, but a CNN,
Mm-hmm.
to predict a house's price. If you and that by itself basically got within about $80,000 on average.
Oh, okay.
So I mean, it could predict, a shack from a mansion. But
Okay. But it wasn't super pinpoint. Like, you should list
no,
your house for this. If
yeah,
I get $80,000 below what I'm asking, that I wouldn't be happy.
no. But then we integrated also realtor descriptions using some NLP, as
Oh,
well as the latitude, longitude, bedrooms, bathrooms, things like that were easily to put out to vector. So we put in the NLP prediction and the CNN prediction into this vector, along with the bedrooms, bathrooms, the average school rating, things like that, and pass that through a neural network. And that gave us about 45 grand in air, I think.
mm-hmm. Getting
And,
better.
we were like, oh, that's still sort of not great. But then we also, when we were scraping Zillow, we scraped the Zestimate, the Zillow estimate of
Oh,
the house value. And
yeah.
we're like, let's see how far off we are from that. And we're only a grand away.
Oh, wow.
And
All
we're
right.
like, okay, well, I think this is good enough for a 2 or 3 week project versus, a team of engineers, probably some PhDs, for this company that's, had this feature for years.
Yeah, yeah. I mean, it's you probably uncovered how they calculated this estimate, in one way or another. I would argue at least this estimate on my house and other ones I've seen have been off. So, like you said, I think they've been off by a lot. I'm like, where are they coming up with that number from? But that's very interesting, I guess. Yeah,
Yeah.
you
No,
guys
we're
really.
like tracking down, how can we 45 to 50 grand is still like atrocious,
Yeah, yeah,
and then you're like, oh, we're we're not far off at all from, you know, probably the experts in the field. So
yeah, yeah. Oh, that's cool. That's cool. Well, yeah. So that's fun. So you had a chance to play around with Spark, like you're saying.
yeah,
With that,
and
that was sort of the underlying tool.
it was, more of a pipelining, you know,
Getting the data.
data all the way to the end. Um, the scraping of the data. Uh, I wasn't personally working on it, but Zillow has really good anti-scraping
Yeah.
measures. And so the solution that they came up with was Google using the Google Cache version of the website.
Mm, okay. So don't even
But
hit their site.
yeah,
Just hit the cache. Yeah.
but instead of then getting that directly from Google was having some issues. So
Hmm.
it was putting the address into Bing, requesting the Google cache from the Bing results, and then scraping that.
Oh, sure. Wow. That's convoluted.
Yeah, and then it was like spread across like the like 5 uh lab machines. It was
Yeah.
just, I'm like, that just sounds not fun, but
No.
thanks for making it work.
Well, yeah. Well, that's well, I guess, as I've seen with a lot of these data science AI projects. I mean, it feels like a lot of the work is just in getting the data and cleaning the data and formatting the data and filtering out the garbage that's still stuck in the data,
Yeah.
to then finally run it through an algorithm to then make a prediction, which oftentimes it's still not right. So now you got to go back and get more data. It's just, there's a whole, like you said, pipelining. That's a good word for it.
Yeah. And that was sort of the issue with the start of the internship too. It's like, well, number one, we didn't get the right computer, so we're waiting 2 weeks for that. And then, you know, but during that time we're like going, okay, what data A do we have access to as interns? And B would actually be able to help us do this.
Yeah, for sure.
Um, and I think actually having those 2 weeks to figure that out was really helpful. And once we got the right tools, we could just hit the ground running and go
Gotcha.
with the actual machine learning side of things.
Sure. Very good. Well, this has been a great conversation. I mentioned at the beginning about being a Eagle Scout. I'm curious if you have any thoughts or perspectives on sort of how that has helped you in your career, if any. It's kind of out of
Yeah,
left field a little bit, but I'd be curious to know.
I mean, I think, well, so for my Eagle Scout capstone project, I built a portable mini golf course for the city of Plymouth.
Hmm.
It was they bring it to events, city events that has a ecological theme. So there's like one with cans for recycling and one with buckthorn for, removing that,
Yeah.
things like that. Um, and I think the most valuable learning experience was the communication and the, team leadership of the whole thing.
Hmm.
Was, you know, I need to show the process and how this should be assembled. I need to communicate that clearly. How to manage a team, 30 volunteers to
Mm.
build these 6 holes. Oh, let's break them up into groups of 5 instead of having them all work on one hole at the same time.
Mm.
You know, just the logistical side of things, I think, was the greatest learning experience out of that. And the communication of a project is huge. I mean, be it in the business world, in the software world,
Yep.
or your Eagle Scout project, you know, saying, okay, we built this thing.
Hmm.
Here's how to use it, or here's how to replicate it, or, here's the choices that we made. Being able to communicate that clearly, I think, is really important. So I think that's sort of what I most got out of that.
Nice, cool. Yeah, no, that makes complete sense. After running my own business and running software teams and being in technology, yeah, it's not all about the tech, really. It really is about communication. As you're running the project, staying in touch with the team, staying in touch with, in my case, a lot of clients, being very clear on where you are with regards to solving the problem. And then once the problem is, I wouldn't say solved, but at least you've delivered a possible solution, then being able to communicate that, whether it be to a manager, to the team or the engineer, or out to the client. It's just, yeah, things make or break based on communication. And getting those skills early on sounds like it really had a fantastic, like a positive impact, I guess, on your career. So that's really cool to hear.
Yeah, no, I thought it was. Scouting, I think, is a really good experience just from that, leadership experience and the experience of having to communicate, you know, to both peers as well as your adult leaders,
Right.
in the troop.
Right. Cool. Well, so how do people get a hold of you, Parker? It's the best place.
Uh, LinkedIn, my email, parker.erickson30@gmail.com. I also have a Medium blog as well as some other stuff, but that's all linked on LinkedIn. So
cool. Well, I'll
uh,
be sure to include these links here in the notes on the show once we finally broadcast it or put it out for the public.
sounds good.
Is there anything I missed? Anything else you wanted to bring in or kind of end off with? Any final thoughts?
Not really. Thanks for having me. I thought, yeah, that's about it. Thanks for having me. Thanks for putting it together.
Yeah.
So.
Yeah, no, I appreciate you being on, and I wish you all the best in your career. I know you're going to do well. You've already done some amazing things already as your second year in college, and very excited to track you over the next 10 years or so and see where things land. I mean, always very excited to promote and help upcoming technologists and entrepreneurs and stuff like that. So I appreciate you being on the show, and definitely going to stay in touch, Parker. So thanks again.
Thank you.
Take care.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at AppliedAI.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at AppliedAI.mn if you are interested in participating in a future episode. Thank you for listening.